nanohub.org.
Online simulation, and more for nanotechnology.
All right, welcome and good day, everybody. Thank you so much for joining us today. I'm Erin Hartman, the webinar moderator for the NanoHub Champion Series. This series will be highlighting some of the tools that can be found and utilized on NanoHub. Today's speaker is Dr. Ray Sanchez-Arias. Ray Sanchez-Arias is an assistant professor in the Department of Data Science and Business Analytics at Florida Polytechnic University. There he teaches courses in data science, statistical learning, scientific computing, and data mining, as well as mentoring research projects with both undergraduate and graduate students. Previously, he served as the program director for the master's program in Big Analytics in the School of Science at St. Thomas University in Miami. He was also a member of the Applied Mathematics Department at Wentworth Institute of Technology in Boston. He earned his bachelor's degree in mathematics from the Universidad del Valle in Colombia, his PhD in computational science from the University of Texas at El Paso, and was a postdoc at the Army High Performance Computing Research Center at the University of Texas at El Paso as well. His general areas of interest include data mining and machine learning, computational linear algebra and optimization, and data science education. Today, he'll be discussing incorporating notebooks in STEM classes and deploying interactive applications and data sets. Ray, thank you so much for joining us today.
Thank you very much, Erin, and thank you to the entire team at NanoHub, and thanks to everybody for taking some time of your Friday afternoon or Friday evening to listen to me talking about some of the data science tools that hopefully you can use for or incorporate in your either in your classes or in your research. So as Erin mentioned, this is the second of a two-part webinar series that we're having this summer. About a month ago, we introduced some tools in the R statistical programming language, and in particular about using two packages that are very popular for data transformation and also for data visualization. I'll refer to those resources later in the presentation as well. And again, if you want to later connect or reach out to me, you can visit my website, and you have links there for all the different ways to connect. And I'm glad that Erin mentioned as one of my interests it is in data science education, and that's something that I've been doing in the past almost 6 years now. So I'm very, very interested in effective ways for teaching and learning data analytics, and I'm very involved in curriculum and assessment at my university and at my department. So this is part of this presentation is a little bit of my own experience in incorporating notebooks, computational notebooks for teaching data analytics. And something that you can find on my website is also some short list of some of the courses that I've taught so far in my career. So as you know, I'm a computational mathematician by training. So that means, yes, I taught classes in calculus, 1, 2, 3, DFQs, linear algebra, operations research, and other things. But my training took me in a direction of the connections between computational linear algebra, numerical optimization, and their applications to data mining and machine learning methods. So that's the reason why I ended up how I ended up in this type of field, and how I ended up trying to explore what are effective ways to teach many of the concepts that we cover in those classes. So in particular, I put this slide here with the different classes because the ones that I'm highlighting right now are actually classes for which I have incorporated computational notebooks, Jupyter Notebooks and R Notebooks, which is the topic of today's webinar. And I'm here to talk about that experience. So any of those courses, if you ever have questions about them, either the content or some of the applications or some of the final projects the students have worked on in that particular class, feel free to email me, or also join the nanohuborg group. And we have a way for you to post your questions on a forum. So why notebooks, right? And I try to capture the goal of this here in a short sentence. And when people ask me why do I use or why do I try to incorporate notebooks in my classes, I tell them that it's because I'm trying to find a way for students to be able to include the code that they develop in the class, the associated output that that code produces, but also include some text and narrative in one single document that they can easily share. Sometimes they want to share that document with me, the instructor, because I need to grade an assignment. Sometimes they want to share that document perhaps when they're going on an internship and they want to showcase what they've done in the final projects throughout their coursework. In addition to that, I feel like notebooks promote reproducibility. They have great advantages in the sense that they're reusable and interactive. You can easily export to a variety of formats, and they're very good for templates. And those are some of the reasons why I incorporate notebooks as the practical component of many of these classes. And this idea of notebooks actually probably is based on a seminal work by Donald Knuth on literate programming, which is a paradigm in which a computer program is given an explanation of its logic in some sort of natural language, including snippets and traditional source code. So nowadays, probably all of you have heard about Jupyter Notebooks, and if you have created an account on nanohuborg, potentially you have had the chance to explore the Jupyter Notebook tool that is available there. Within nanohuborg, there's also a tool which is the RStudio IDE, one of the most popular integrated development environments for programming in R. So a Jupyter Notebook, even if you don't know about it, so hopefully you can take this as an invitation to learn more about it. A Jupyter Notebook is simply an open source web application to create and share documents. And again, they follow that paradigm. That means that they contain live code, they contain visualizations, and they include some sort of narrative text. Jupyter actually stands for Julia, Python, and R. So that's why I use different colors here for the word Jupyter. And within nanohuborg, you can actually use Jupyter Notebooks, not just to program in Python or program in R, but you can also program in Julia and other languages and sometimes combine some of them, which is really, really cool. So they're very useful for data analysis. They're useful for numerical simulation, for statistical modeling, for prototyping, for data visualization, for statistical learning, and several other applications. And if you navigate our resources on nanohuborg, you can find many of the contributions that some of the members of the community have made available to you because they focus on one particular problem, they develop a Jupyter Notebook, and they want to share that with the community. An R notebook, on the other hand, is what we call an R markdown document. This includes chunks that can be executed independently and interactively with output that is visible immediately beneath the input. They allow for direct interaction with R while producing a very good and reproducible document with high quality publication, almost ready to be shared with anybody. So a lot of us actually do some of our preliminary analyses on an R notebook or a Jupyter Notebook and use some of those snippets and some of the things that we write or create when working in these notebooks for the follow-up paper associated to that type of research, for example. Again, I wanted to bring to your attention that you can program in R in nanohuborg using the RStudio tool, and that's why I'm including the direct link for it. On the right-hand side, you see a snippet, a screenshot of how the RStudio environment would look like when you launch it. So it has all the tools that you would expect in an integrated development environment type of tool. And it's also free of charge if you want to install that in your computer. you can easily install R and R Studio. This is the reason why I'm focusing on this type of open source tools for this webinar series. Additionally, as I said, you can also launch a Jupyter Notebook within NanoHub. That's the direct link on this slide. And on the right-hand side, again, I'm including a screenshot of how it looks like. And even though in the previous screenshot, I didn't explain the different components of that particular R Markdown document, in this slide, I want you to realize that even if you have never programmed in R or in Python, let's say, when you see this type of screenshot, you can realize that indeed there is some narrative text. Indeed, there is some code in these cells, and right below those cells, there is some output associated to it. The good news is that if you incorporate this type of tools in your teaching or in your research, then you can share this with anybody, and they won't have to create accounts, or they won't have to download anything, or they won't have to install anything on their computers to be able to learn about your analyses. And that's one of the big advantages of this type of frameworks. If you're new to R, make sure that you take a look at the materials that we shared on our first webinar series about a month ago. The team at NanoHub already published that resource, and you can access that if you follow that link. I believe we also already shared with you the link to today's presentation, and you should be able to click on any of these links, and it would take you where they're supposed to take you. And within that webinar, we actually covered three different things. We introduced R briefly, and then we introduced two powerful tools for any type of data analysis or data science project. Those are dplyr for data transformation and ggplot2 for data visualization. We also have a tool that I developed as part of this program for showcasing how this set of functions that are available in these packages could be used to illustrate certain applications in some STEM disciplines. So we have a series of different case studies, let's call them, where you can just go and interact with the Jupyter Notebook. You can run the code yourself. You can modify it and see what the output would be in those cases. So we have some sample STEM applications for you to play with. So here's a little walkthrough on how that looks like, and just to kind of motivate you to actually explore it. We have slides for you that explain the main concepts behind these different packages and the Tidyverse framework, including, again, data transformation, data visualization, and dealing with different types of data types. And we have at the bottom of the homepage, we have these different case studies that you can navigate. So there's an application for environmental engineering, or there may be an application for civil engineering, or just for biology, for example. So coming back to teaching with notebooks and why do I do it, or why do I try to incorporate those in my work? Again, one thing that I'm very focused on is in trying to aim and promote reproducibility for any type of data analysis. By that I mean that if you tell me that you obtain certain results and you have worked hard on creating clear code that produces your analyses, I want to be able to reproduce those results if I have the exact same code and the exact same type of data set. So this is something that we try to promote within the data science field, because me as an instructor, I always find cases where students in the past would say, I don't know what happened with my code, it was running yesterday, but when they're trying to present it, it's not working anymore. So by promoting reproducibility through the use of notebooks, we're trying to hit that target. The other reason why I use them in my teaching is because I want to incorporate these computational notebooks as class demonstrations and classwork activities, and follow up homework assignments that look very similar to those. So I generally try to introduce a topic, and I provide a template for my students to test the things that we're discussing. And I'll show a couple of those later in this presentation, but I'll tell you why I give them a template. And the main reason for that is that I describe that notebooks include code, the output of the code, and also some narrative text. So I want to provide them with that narrative text already. I want to provide them with some definitions. I want to provide them with some problem formulations. But I want them to, when they come to class, they actually spend some more time programming and testing the different tools with me. And what I have observed already is that many of them just, expand on whatever I write or write their own clarification. So it's a very actually good way to take notes for them. And at the end of the class meeting, they actually have a product that they can save in their computer and they can share with anybody else. And whenever they need to study, they can review it. So when I said that they can share it with anybody else, it's because notebooks can actually be exported as an HTML file. And that basically means that if you send me the results of your data analysis on an HTML file, then I should be able to open that in any type of web browser. But also, students can easily upload that type of notebook that is in HTML format to your favorite learning management system. So in my case, in the past, I've used Blackboard. Now in this university, we use Canvas. And it's very convenient for me as an instructor to see a very standardized set of submissions and to be able to provide feedback because the students have uploaded this file that is easily rendered in the learning management system. And finally, the students get used to creating a narrative, explaining the code they use, and commenting on the results. So this is something that is part of every other assignment. In the past, if I was teaching a programming class, perhaps I would run into students that would not leave a single comment on their code, right? And now I'm trying to tell them, well, whatever you write, whatever set of instructions you wrote to accomplish or to find a solution to a problem, I need you to comment on those results because that's part of your notebook. I need you to tell me why you did the things the way you decided to do them. So I'm very proud of seeing several of my students very, very good at this because it's going to help them later when they're trying to explain any type of concept or show results whenever they go and join the workforce. Following up on teaching with notebooks, the computational work is I want to talk about reproducibility again. So it is reproducible if I can take the data and the code and produce the same results. So for example, that would allow me to check if the tables and figures are reproducible from the code and the data that my student provided to me. It would allow me to check if the code actually does what I think it does. And in addition to what was done, it would allow me to check if it's clear why it was done that way. And I put the title of this slide, I said teaching, but this also applies to research. It would be great if every time we read a research article, and let's say is submitted to a peer-reviewed journal, and maybe you're one of the reviewers, it would be great if every article actually comes with an associated notebook that you can check some of the code that the researchers use to produce the results they're claiming on their paper. That would make it a lot more open, and it would really help us in this issue of the reproducibility crisis that sometimes we find in some disciplines. And I'm putting a little symbol here with kind of a warning sign because reproducibility is a minimal type of standard. That something is reproducible does not immediately imply that it is correct. The code may have some bugs, maybe it has some typos, maybe we misspell the name of an attribute and we ended up using a column of our data set that really shouldn't be used. The methods may be poorly behaved, or they could be some other experimental artifacts. However, reproducibility is probably associated with correctness, and it would allow us to quickly pinpoint to the cause of any type of issues or concerns. So here's a Jupyter notebook, and again, if you're familiar with it, that's fantastic. Hopefully, after this presentation, you can learn more about what we do in our notebooks and the type of materials that we can create or data products that we can create. But those of you that are new to notebooks, let me show you a screenshot of how it would look like. And here's a screenshot of one of the notebooks that we developed for the first webinar on an application of data analytics for civil engineering, studying a data set that has a lot of properties for concrete compressive strength. So what we see here is that this one document includes some text and narrative that actually follows Markdown style that allows us to typeset our document in a very professional way. It also includes some code, and right below that, it includes the output of that code. So this is the type of minimal structure that we can have. And of course, as you get more and more familiar, you may decide to make your notebooks more sophisticated. Maybe they will have some collapsible menus. Maybe they will have a lot more hyperlinks. Maybe they will have multiple pieces and tabs. And there's many great notebooks on NanoHub. So I invite you to actually look at some of the resources that the community has provided to you, because maybe it's of your interest, or maybe you can use it as a sample to do something in your own discipline. For the case of an R notebook, here's a screenshot of how that would look like. So again, I'm showing a screenshot of an R Markdown file. This is why the extension of this file is RMD. And this example is also one of the examples from the first webinar. So it has the same characteristics. It has some text and narrative, some code. Code chunk is the name that they give in the R community, that we can use to run, and we can write some code and take a look at the result that we produce. And all of this will live in our IDE in this case, or in the previous example, it would live on the Jupyter Notebook. And in addition to that, as I mentioned, is using notebooks is really good for flexibility. It provides you a good flexibility for formatting. So notebooks actually support Markdown, as I mentioned, and also text. So it's not unusual that my students see me give them a template that actually includes a lot of equations, because perhaps when we're covering methods from statistical learning, I include some of those equations and those problem formulations within their notebook, and I try to typeset my document as professional as possible for them to take good, high quality notes as they're being exposed to these topics. So the example that you see on this figure is simply the result of previewing this notebook in HTML format, following again Markdown and tech in this case. So this means that if you're an instructor, or if you're a student, you can actually create high quality reports of any type of work you're doing, either for a class or for your own research. And this is the reason why I have decided to incorporate it not just in my classes, as I mentioned, but also in my research, because it allows me to quickly reuse things that we've written before, quickly reuse equations that we have typeset before, and get it all faster, which is great. So let me tell you about using templates, right? Because I mentioned that I like to use notebooks in my classes because I like to provide my students with some sort of template that they can open in their favorite system. If it's a Python type of notebook, maybe they use Jupyter. If it's an R Markdown file, maybe they use RStudio. But I provide my students with a template after introducing a particular topic, and there's a couple of things that are missing in that template. Sometimes the notes are not complete. Sometimes there are open-ended questions for them to answer in the narrative text component of the notebook. But always, the code is missing. So that way, when those students enroll in my, let's say, for this particular example, in my data mining and text mining class. Students attend the lecture, they get familiar with the methods, and then we practice, right? We got to practice and we got to show that we can use some tools, some modern data science tools to solve a particular problem, and then we can comment on our results and we can explore with a variety of data sets. So that's how it works in my particular case. You're seeing a screenshot of my Canvas page for the data mining and text mining class, where we introduce latent direct click allocation, a method for fitting a topic model, and then the students can go ahead and download that file and find out that there's a lot of notes already taken for them. And what we need to do in class, when we have some quality time and some time to discuss things associated to the course, is to actually test the code that will help us solve a particular problem. So here's the example of that notebook in particular. That art notebook was to introduce students to the methods behind topic modeling, in particular latent direct click allocation. And what I do is I give them, in this example, a data set that includes a lot of text that's coming from TripAdvisor reviews for the experience that any visitors to the Camp Nou had. The Camp Nou is the Barcelona stadium, which is my favorite soccer team. So that's the reason why I included that. But as you can see in this region, there is code missing. So there is nothing there. So if they don't go to the class, or if they don't, let's say, watch the video of me going through the analyses, they won't be able to complete it, right? Or if they don't read before, finding out what are the good ways to solve that problem, they won't be able to complete it. On the right-hand side, what I'm showing is, okay, here's the type of code, and we do this together in a classroom, so they can see me doing live coding and interacting with my notebook, which is a key property of incorporating notebooks in your teaching and research. So I'm interacting with my notebook, and sometimes, of course, I make mistakes. Sometimes I didn't expect to have that mistake, and we try to troubleshoot together. So it's actually a great learning experience, and it's something that students really value, according to some of the feedback I've gotten of incorporating notebooks this way. In addition to that, after almost every one of these classwork activities, there will be a follow-up homework and set of problems that have a similar structure, right? So the homework may have already set out for them some questions, and they have to take more initiative in placing code in the right portions of their notebook and explaining why they did the way they did it, and of course commenting on their results. So here's an example of that. Here's an example of providing notebook templates for homework. So for me as an instructor, when I first started incorporating them in some of my courses, it was a natural thing to do. If I had designed this computational notebook for a class activity, well, I'm going to try to follow a similar process to design a homework assignment to test and give students the opportunity to have more creativity and solve other problems and whatnot. So here's again a screenshot of my actual Canvas page, which is the learning management system for this class. This is the first homework where they have to solve different problems associated to data summaries and pre-processing. And as you can see, there is some notes about, hey, here's this other problem, but there's a couple other things that I want you to pay attention to. The first one is that there is a template for them to use. So in this very first homework assignments, I'd like to give them a template. So that is a very standard set of submissions that I'm going to be getting, and also to help them with building a good homework, right? So this gives me the opportunity to have very similar homework assignments when I review them. The second thing is that I'm requesting that they upload the result in HTML from their notebook. And we haven't yet talked about how do you create this ones or where do you click, and it will depend on what type of platform you're using. But the key message is that if you have your computational notebook, you are allowed to produce easily these HTML outputs, which is fantastic. And then the last thing is that I also have, since I created that template for that homework assignment, I have an HTML version of that assignment that I can easily render in my learning management system. So me as an instructor, I pay close attention to the design and the aesthetics of my Canvas pages and the resources that the students will have. But this is also a selling point for me because I do one piece of work by designing a good assignment, and then I use the products that I can obtain from that particular computational notebook in my assessments. This particular homework assignment also had some information about what was the purpose of the assignment and how did it align with my course learning outcomes for this particular class. Okay. In addition to that, well, you can use notebooks to share the solutions to the problems, right? If the problem that you're given is missing, of course, doesn't have any code to solve the problems, well, it is good practice sometimes to either provide the students with the entire notebook or simply sometimes create a screencast or take 10 minutes of your next class and actually solve the problem or solve some of the problems that the students struggle with. So in here, you see me providing students with some solutions. That's why the title of this one says Solutions for the Spring 2018 of a Homework Assignment for an Applied Machine Learning class, in which they were testing supervised learning algorithms for classification problems in digit recognition in this case. So again, all I'm doing is taking the exact same template that their students were provided with and solving it either through a video, through research time during class time, and sometimes depending on our schedule, just by telling them solutions have been posted, go ahead and watch them or read them and find the tricks in that case. So very good for sharing solutions. The other thing I wanted to mention in terms of Jupyter Notebooks is that, of course, you can have your Jupyter notebook running a Python kernel or an R kernel. And this particular video is actually navigating the Jupyter Notebook tool from nanohub. So you see it on the top left here, the logo. So what I did is I just wanted to show that there's a collection of packages and libraries for R and Python that are already available for you to just use notebooks for a variety of problems, either if they're homework or teaching materials or just pure research that you're doing. And if you ever run into a situation where you find out that a particular package or library is missing, please just submit a ticket, and the team at nanohub are fantastic at making sure they install quickly the set of tools that you need to move on with your goals. So that's a little piece of advice. Don't hesitate to do it. The other thing I wanted to mention is about formatting Jupyter Notebooks, right? So I mentioned, of course, we use it for class. Sometimes I provide my students with a lot of notes. Sometimes I even have decided to provide materials to my students that maybe is not in one single book, or maybe is a solution to a problem that requires some mathematical computations or development, and I write it down in the same platform. I create a notebook as the one that you see on the left. So you're seeing the source code where I'm basically simply using Markdown and what I know from LaTeX, creating some hopefully clear explanations for a topic on maximum likelihood estimation, and defining some log likelihood functions in this case, but providing them with this. That also, I have noticed, has motivated several of my students to actually get good at typesetting and creating better quality notebooks, because when they see that they can easily produce something that looks very professional, that looks very similar to what they would find on any book they would open, they get excited, and then they start asking questions about, can we also do collapsible menus? Can we have sections? Can we have a footnote? How do we do a reference section? So I try to format my Jupyter notebooks as good as possible in certain instances to try to motivate students to do it. And as I said, since I also incorporate them in my research, then this is very, very useful in those cases. Because if I need to write a paper associated to that let's say applied research project, then I have already made some progress, right? So I don't just have the code; I have something that, in my mind, was done in preparation for the final product of writing a research article. Let's talk about portability. So I did mention that notebooks can be exported to several formats. On the right, you see a screenshot on how to do it if you're working on a Jupyter notebook. Again, I'm using the example of one of the notebooks we created for the first webinar series. And in this case, it only takes basically 2 steps. I go to File, I click on Download As, and then I can see all the options that are available, right? I can download this as an IPython notebook. That's what IPYNB stands for. I can download just the R code from it. I can download it as an HTML, which is the option I ask my students to generate their notebooks and upload them to the learning management system. And then there's several other options, including LaTeX, which is actually very convenient to start writing your papers, is that's what you typeset your papers on. The other good thing about it is that GitHub is able to render IPython notebooks and Markdown files, and we can also knit our Markdown file so that it generates the associated Markdown file that includes all the outputs and the figures that can also be rendered on GitHub. Why is this important? Because if you have a GitHub profile or maybe a GitHub associated to your project and you're working and collaborating with other researchers, you can just send them a message and say, everything has been pushed to our GitHub repo, and you can see the solutions in this notebook, and then everybody has access to it, and they don't need to run anything. They can just see what you did to produce the results that you're claiming you obtained. So portability for me is really, really important, because not only I want to export my notebook in HTML for my homework, but maybe I want to reuse that, as I said, to create a presentation for the final project, which is something you could potentially do. Here's the other way to take a look at the variety of formats you can have when exporting your files. So in this case, some of you may be asking yourself, can I actually export this in some of the traditional word processing software? And so if you want to generate a Word document from your notebook, you can actually do it, which is great news. And what I did for this particular webinar is I took 3 of the notebooks we discussed on the first webinar, and that you can explore, and you have access to it through the links that we have provided you in this set of slides as well. And I push all those outputs on a public GitHub repo, so that you convince yourself that indeed it took little to no effort to create this output in different formats. So here's a video of that. Here's the GitHub repo that you can visit. Here's the IPython notebook that it actually is absolutely okay and totally correctly rendered on GitHub. So this is me navigating that particular version. Here's the PDF version of another notebook. So Of course, there's some things that we may need to format, but a lot of the heavy lifting is already done for us. And here is me seeing if the Word document version actually works. So I downloaded that file, and I open it up, and the tables are good, the code is good, the comments are good. So that's great news, because it really helps me create a variety of data products from one single source. So when I mentioned, if you decide to use these tools, not just for reproducibility, but also it's going to be convenient to reuse many things from notebooks that you generate for either teaching or research. All right. And this one, the final one, is the Markdown version that's also easily generated from the Jupyter Notebook associated to this particular application. So the link is there. You can see them. I showed the video in case you wouldn't believe me, but of course, you can visit the GitHub page and see them yourself. So I talk about reusing them, and I'm going to focus on this second part of the lecture mostly on using R Studio and R Markdown for it. The first part of this webinar series, I focus a lot on Jupyter Notebooks, but I also want to bring to your attention that you do have access to an R Studio IDE through nanohub. So R Markdown documents can be used to generate, as I said, many different formats. You can create a PDF file, you can create a website, which is fantastic. You can create a dashboard, you can create an interactive application, you can generate the HTML associated to your notebook. There are many resources out there nowadays, but by far the work by Yihui is one of the best in terms of the definitive guide for R Markdown. So he on his bookdown book for R Markdown goes through many of the questions you may have when assembling a document and thinking about sections and subsections and reference systems and others. So there are resources for you, and if you follow that link, it's absolutely free of charge. Here's another illustration by William Chase, in which he highlights that R Studio, and in particular, the combination of these two packages, R Markdown and Meter, allows you to create many things. On the far left, you see Bookdown, and in fact, that's the way that many of the open source resources that we have in the R community nowadays, like the R for Data Science book, are presented. So if you Google R for DS, R, the number 4, and the letter DS, R for Data Science, you're for sure going to find the link for that book on the bottom left. And that book is built by using a package called Bookdown. That is, if you read more about it, you'll realize that if you know how to work with notebooks, you definitely will be able to publish your own books. Many instructors nowadays, in the past 2 years or so, have started actually publishing their own notes through a Bookdown. So that way students have access to their notes or access to exercises and whatnot. You also can create presentations, including PowerPoint presentations or Beamer presentations, which is the type of presentation I used to do 10 years ago because I was trained as a mathematician and I used a lot of LaTeX. Reveal.js, iOS slides, very professional presentations. If you follow the link to any of the 3 set of slides for the previous webinar, all of those were created within R Studio using R Markdown. And that means that I can create my slides that easily include code and the output of the code. And I no longer have to copy the code from, let's say, my Python editor and then pasting that into PowerPoint and then taking a screenshot of the output. I can just have an actual document that includes everything and is formatted in a slide version of my content. We talk about generating HTML documents, PDF, LaTeX, interactive notebooks, and dashboards. And then on the far right, you see this other tool called Blockdown. which is actually how I built my website. It takes very little effort. It's all based on things that you probably can navigate as you get familiar with notebooks. And that's literally how I built my website and how I update the website. To give you more motivation to explore some of the packages and great contributions from the R community for reusing, let's say, this idea of literate programming, I would like you to take a look at Flex Dashboard. This is a project that had as a goal to make it very easy to create interactive dashboards for R using Markdown. The link will take you there, but as you can see on the left, what they have on this template is a title, the type of output that we're going to generate, which is a dashboard type of output, and then everything else is Markdown with some sprinkle R code, which is fantastic because that means if you create a notebook and you want to create a dashboard later on, you can reuse some of the things that you've already done. There's great examples, and what I like about them is that if you navigate some of these examples, you have the source code to generate that. So you can literally use some of the things that the community has contributed to the website and take a look at how to accomplish what you really want to do. That may be, plotting some results as a model. That may be showing the results of a clustering technique. That may be creating an interactive map. And the reason why I mentioned interactive maps is because actually last year, earlier during the pandemic, the city of, I believe it was Salt Lake City in Utah, the team that was working for the Department of Health actually published a Flex dashboard. And I know that because when I first saw it, tracking cases, and plotting those in a map and putting information, I knew for a fact that it was using Flex dashboards. And then I found it and it was a great example to show my students. So it is a good skill to have, and it's definitely a skill that allows you to quickly share your results and have a lot of impact in that sense. Here's the Flex dashboard example in the RStudio tool on NanoHub. So you can see that the URL here includes the word nanohub.org. And I just wanted to show it to you so that you're aware that you can actually start exploring some of these things, checking some of these examples. And all that it takes is getting some familiarity with the syntax. But the idea of literate programming and computational notebooks is basically all we're using in this case. So myself, and I'm sure many of my colleagues are very grateful for fantastic work that the community has done in creating these professional packages that really help us get out there and communicate many of our results. So check it out because it's really cool. So I talk about our Markdown. Here's some final thoughts on it. Again, it's very great for reproducibility. The output is self-documented with embedded code. If you're using our Markdown, a difference between that and our notebook and our Jupyter notebook is that you have to run it successfully from top to bottom in the select format. It is also human readable in version control. So by that, I mean, if you're working with somebody else, you have a GitHub repo associated to your project, you can quickly find the difference between the two versions that the two developers contributed to the project. So that's really neat. So definitely take a look at it if you never explore it. You can also use the link on the bottom right of this slide and see some of these lessons that are already available there to produce different type of quality documents. The other thing I wanted to highlight about it is that we discussed this idea of reusing, right? And let's say you're trying to generate a report that you have to provide every month or every week or whatever it is. And this report depends on some parameters. Those parameters may be the names of your customers. Those parameters may be the results of your simulation, or it may be the day when that simulation run. In this example, I'm showing how you can easily work with an R Markdown document that includes parameters, and in this case, is to explore a data set that includes all the flights that left the city of New York in the year 2013. And it turns out that that information, that big data set, it has more than 300,000 rows and several columns that include the departure delay, the schedule arrival delay, where was it going, what's the name of that airport, what was the total distance covered and whatnot, what was the company and other inputs, other parameters. So I decided to use just one. And the one that I decided to use is the destination. So earlier, I don't know if I mentioned it, but definitely Erin mentioned that I'm an assistant professor of data science at Florida Polytechnic University. This is the newest state university in the state of Florida. And we are in the city of Lakeland, which is almost equidistant from Orlando and Tampa. So I used the airport code for Tampa, which is TPA. So what I wanted to show is that within the Markdown file, I can define the parameter, and then I'm highlighting here the pieces of this document, this notebook, where I'm using that parameter. I'm using that parameter to get a subset of the flights that went to Tampa. Then I'm using that parameter to obtain the name of Tampa Airport because TPA is the code. And then I'm using that to build the title for my final plot. And when I run that, the result of the of meeting this document is shown on the right-hand side. So it's a document that says, here's all the flights that left the city of New York in 2013, headed to Tampa. Here's the average departure delay per month. And then I created a plot just to remind you that basically the first block that you see here is what we practiced in one of our lectures for the first part of this webinar series on data transformation and data summaries. And the second part is on data visualization. So I created a simple bar plot that shows how many flights we had that left the city of New York, headed to Tampa in the year 2013. So a couple of things you notice here, of course, that there's a lot of visitors in November and December, maybe because they're coming to a warmer weather. But then I decided to rerun it, right? And all I needed to change is the parameter. So I changed the parameter here. Instead of TPA, I changed that to DEN for the airport in Colorado. Everything else is the same. I didn't modify this. I just rerun my notebook, and then the results, of course, change, but I don't have to worry about that anymore, right? So this idea of reusing what you create, I'm really trying to put the message that is, for me, is very attractive. And then, of course, if I was checking this plot, I would try to confirm, would it make sense really that folks are, headed to Denver like in the summer, coming from New York? Maybe it does, maybe it doesn't, but definitely it's a different plot than the one in the previous slide. Okay. A quick note on Bookdown. As I said, it's an open source R package that allows you to easily write actual books and long form articles or reports with R Markdown. It supports many things. You're allowed to publish it on GitHub. It is well integrated with the RStudio IDE. and you can write LaTeX on it, supports several languages such as R, C++, Python, SQL commands, and others. So definitely check it out. The documentation is great. And a project that is very similar or headed in a similar direction is Jupyter Book. So this one, of course, based on Jupyter Notebooks. So it's also an open source project, and it helps you build beautiful publication quality books and documents from computational material. So as you start building the notebooks that you want for either a class you're developing or a research topic, consider in the future maybe getting them all together and making this available in kind of a book format. Almost finally, I wanted to talk about Shiny applications. These are interactive web applications. These are specific to our programming. It is a complete web application framework for interactive visualization. It allows you to easily create this web application where the user can, click on drop-down menus and see how the plot would change, can take a look at a table and filter that table based on conditions. So it's really, really cool and really, really easy to get started and get super, super advanced. So it's a great package to explore. You can also host standalone applications on a web page or embed them in our Markdown documents or build dashboards. And I believe you can also work on one of these ones and deploy it as a tool on nanohub. So our studio actually has a whole website to help you get started. It has a collection of videos and exercises to help you understand what are the functions that you would need to create your web application. So just like we did in the past with, when we had a discussion on dplyr and ggplot2, and what functions are important in there. Of course, you need to master some functions from Shiny to create the user interface that you're sufficiently satisfied with. There's, of course, many other sophisticated examples also on their website. And I'm just going to skip through this one because the one that I like the most is the COVID-19 tracker. So there's an entire COVID-19 tracker that was actually built using Shiny web applications. So the code is available so that you can actually see which functions are being used and how are they pulling the data, what type of API functions are using to connect with official data, how are they creating the map that's interactive. And it's a really, really good product that easily allow this team that work on this project to provide something to the public for the good of the people using data science and data analytics tools. Again, you can learn Shiny by taking a look at the different available tutorials. What I traditionally like to do is go through the gallery looking for some inspiration for things that I think look like something I may want to implement. About 3 years ago or 4 years ago, I actually created a Shiny application for my wife and her group, who were at the time, she was at the time working for the biomedical engineering department, and her students needed to easily upload an Excel sheet and get some summary statistics and get a trend line. And that's all they needed to know when we had a discussion. And now they use it, right? So they have a standalone web interactive application where they get results from the machine, they upload those results, and they produce a report. So there's a variety of Shiny interactive web applications that you can think of, as simple as allowing the user to play with interactive visualizations, or more sophisticated that can get an input from the user, in this case load a data set, and produce a report. Finally, there's something that's a kind of a recent project still being developed, and every time I go back and check how they're doing, they're making great progress. And this is the Learn R package. The good news about it, because I'm trying to convince you to use notebooks, either Jupyter Notebooks or R Markdown documents. The Learn R package actually makes it super easy to turn any RMark document into an actual interactive tutorial. And these tutorials can include many things. Of course, they can include narrative, figures, illustrations, and equations, just like your notebook. But you can also include code exercises, quiz questions, videos, and even interactive Shiny components. It's a great project that I invite you to take a look at, because that will be the next step. And here's a screenshot of a sample interactive tutorial that they have, where you can see a couple of things. You can see that there's sections, and those sections are defined through an R Markdown document. There is some narrative explaining what a particular function would do. There is some sample code that the student or the person going through the tutorial can run or can submit as an answer. And then there's exercises. And within those exercises, there's also the option to provide hint and provide automated feedback to those that are using these tools. So for educational purposes, and at least for me, that I'm interested in data science education, this is a great tool. This is something that I'm currently exploring and seeing. I have all these materials. How can we make an interactive tutorial available to more people? How can I show some of the examples that I provided for my students? Or how can I have my students go through a set of concepts at their own pace, because it's not always going to be smooth that they come to class, they see me live coding, and maybe something happened on their computer and they couldn't keep up with the pace. So if they do it at their own time, that's awesome. And it's a package that I wanted to highlight for today's presentation.
Thank you for that, Ray. Pablo asks, is there a similar tool to create nice-looking algebra-based notebooks similar to the LaTeX format, but using a tablet or some writing device to write a deviation or equation?
Okay, that's a great question, Pablo. I think I'm aware of some members of the R community have worked on what they call add-ins or extra features for some of these packages for R Markdown, where you can generate your slides and then have a slide that is just a blank space for you to draw something. So if that's what you're referring to, there may be a way for that. And in terms of using a tablet, the good news probably is that if you use any of these resources on NanoHub, you don't have to install anything on your computer. You can just create an account, and you're using NanoHub resources and their server to run everything on the cloud, or technically on the cloud. So that's something that you may explore. I think if you're trying to incorporate notebooks for the very first time and don't want students to struggle with installation, it's a very good way to go, simply because you're passing that barrier sometimes that the student may have a significantly faster computer than the rest, or others have a significantly slower computer than the rest, or others may have a tablet where there's no installers for either Jupyter Lab or R Studio. So definitely take a look at that. You could potentially create a group within NanoHub in this case, and kind of manage your class through there, and everybody can be a member of a group, and you can share resources and answer questions associated to it. So there's a couple of things that come to mind right now.
Thank you for that, Ray. Does anybody else have any other questions that you'd like to ask? Oh, here we go. We got a new one from Antonio. Does R Markdown support Python code?
Yes, that's a very good question. It supports Python code. In fact, this is a somewhat recent development in the past year and a half or 2 years. They managed to do it through a package called Reticulate. So if you Google Reticulate, 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 you'll be able to find some examples of that. So that's actually super cool because you can have an R Markdown document where you can execute some chunks of code that are R code and others that are Python. And there's always a question, which one do I decide to? And a type of answer I sometimes give is that, you can speak both, right? So if you have a tool that allows you to speak both or use both in this case, why not do it? So look it up. It's called Reticulate package. So that's a package that you can explore.
There is a comment. No questions. Just wanted to say thanks for the very informative and interesting presentation, Ray.
Thank you. I'm glad it was useful, and hopefully you get encouraged to explore some of these tools.
Oh, and it looks like we have another question from John. I was using Jupyter Notebook on NanoHub, and I uploaded, and I'm going to say this wrong, PyCalFad. This will be visible. Will this be visible to everyone or just my area of the server?
Hi, John. Let me see if I understand it. So if you're just creating a notebook that lives in your account on your profile, that's only visible by you. But if you deploy your notebook as a tool and made it public, then others can use it. So if that's where you want to head into deploying a tool that is accessible by everybody and everybody can explore, that's great. I think that's the idea of this community. But if you're still in the development stage, then it's only just for you.
Thank you for that response. I just want to take a quick moment and say thank you to everyone who attended today, and hopefully we'll see you for the next series.